All right, let's begin. Today's exercise, 7D. So let's say you've learned 7C pretty well. You can read mapping notation. You can read mapping notation now. You can rearrange it to get the new equation. Then what they're going to get you to do now is they don't give you the sequence of transformations, but they give you the starting equation and then the new equation. And they want you to find out what the sequence of transformation is. So that means you're going backwards now. Okay, so now you know that this is the original xy, and technically this is your new y, new x. That's what it is. Okay, so they're telling you you're going from this graph to this graph. So that's your new y, that's your new x. What makes it a bit challenging is because when you're moving backwards, it feels a bit more confusing than what we did before. But your goal is to find this. And that is find x dash, y dash. If you can find what x dash equals to and what y dash equals to, which is those two, you can then read it. So, hence we're going backwards. Let's go backwards. So here, what you need to look at is this is now your new y and this is your new x. All of this is your new x, right? Now we're doing a comparison. We look at the two. Can you see how this one has a root and then there's something inside the square root? That's your x. That's your original x. So that means original x is currently being replaced with whatever's in the square root sign, right? So I can then say, if I'm moving backwards, I can say original x must equal to 5x dash minus 2. True, because that's what we can see. There's a comparison there, because we have to resubstitute it, right? And then we can see over here, well, that's original y is being replaced with new y. So then I can then state new y is equal to original y. So from this, now that I can see that comparison, remember our goal is to actually solve for new x, new y, because that tells us the transformation. So here, it's the reverse. Now we're moving everything backwards. Our goal is to find what does x dash equal to and what does y dash equal to. Conveniently, y dash is done. Y dash actually just equals to y. So what that means is in your transformation box here, I now know y dash is just equal to y. So that means there's no transformation to the y corner. You just leave it as it is, right? That means all the transformation must be on the x coordinate. So here we're going to rearrange all of this. We're going to say, let's move backwards. Let's try to get x dash. So if I move backwards, I'm adding 2 to both sides. So this now becomes x plus 2. And I've got 5x dash. So I'm moving backwards, yeah? I'm going all the way back to the very original point. I want what x dash equals to. So here what I would have done is I would have divided by 5 on both sides. And that will now tell me x dash is equal to x on 5 plus 2 on 5. This is x dash. That means if I go backwards, in this box, I'm taking original x and I'm dividing it by 5. Or another way of thinking about it is 1/5 of original x. And then I'm adding 2/5 there as well. So now if they ask you, what is the sequence of transformations? Because that's what the question's asking. They're saying, find the sequence of transformations. You can now read this. Because I've got x dash, I've got y dash by moving backwards from the transformation equation. I move backwards. So let's read it. What does the 1/5 do to the x? So that 1/5 is really just getting that x divided by 5. What's that? How do you read that transformation? 1/5 times x, so BODMAS, going BODMAS. So times first before you add or subtract. When you times by 1/5, this is it dilation, reflection, or translation? Dilation. So you got to write it properly. So dilation of factor, what's the factor? 1/5. Very good. It's factor 1/5 from? Very good. From the y-axis. Don't get it confused with the x-axis because you're moving away from the y-axis in order to affect the x-coordinates. Next one. There's no reflection because I don't see a negative anywhere. So it can't be reflection. That means the last one you have is that plus 2 and 5. What does plus 2 and 5 tell me? Right by 2 and 5. This is a translation. So your proper language is translation of 2/5 units. Now in the past you actually had to say positive direction of the x-axis. Now you can actually just say 2/5 units right. And that's okay. The sequence or the order of the sequence has to follow BODMAS, or from yesterday's lesson I said Dr. T. Okay, Dr. T just follows BODMAS. So you do original x, I have to times it first, and then I add according to BODMAS. Okay? How's that feel so far? Because that's technically the hardest of chapter 7, going backwards. Yeah, so if you felt pretty good going backwards, that's pretty much what you practice in 7D. So 7C was read transformation, mapping notation, rearrange, get the new equation. 7D is taking a new equation and going backwards to read the transformation. I'll do one more. Let's go to the bottom. Example 2. Let's have a look. So again, same thing. I'm taking this graph. So this is my original graph, and I'm moving it to y equals x squared. Sorry, I just realized I wrote this wrong. Should be the other way around. So this should be y equals to 3x plus 2 squared plus 5. That's your original function. And you are moving it to y equals x squared. It matters because you need to know which one's the old x and the new x and all that. So that must mean this is new y, new x. All right, team. Let's do the same technique. So we're going to go backwards now. Now, in order to do backwards, there is a little caveat here. Can you see in the original equation, this is something squared. So I know the function is a squared. What I'm replacing is this. I'm replacing 3x plus 2 with x dash. The square's still there. Square's still there. I'm replacing this with x dash. So that's where I can connect them and say, that must mean x dash is equal to 3 times x plus 2. That's clearly what I had to do from here to get to there. I had to replace 3x plus 2 with x dash. That's how I get here. But notice for the y though, y is a bit different then. If this affects the x is in the squared, what's that plus 5? See, that plus 5 has nothing to do with the x. It's not an x transformation. It is the y transformation. But the y transformation is over here. So that means you actually have to move the 5 back to where the y is so that you can do a comparison. Right? Because we had to replace this with this. But that plus 5, where did it come from? So now you actually have to rearrange a bit. You have to move this back over here so that you can say, well, that's y minus 5 is equal to 3x plus 2 squared. And that's why we can then say, this is the x transformation that connects with this. And this must be the y transformation that connects with that. Because you have to think backwards. How did I go from here to here? I had to replace y minus 5 with y dash. That's the only way these two were replaced. And then the square is always there. But what I'm replacing is the x. So 3x plus 2, I'm replacing it with x dash. That's the only part that gets a bit tricky with exercise 3D. Yeah, so if I wrote it again, that means you have two things now. You got y dash is equal to y minus 5. Now this is where some students get confused. If you look at the first example and the second example, what's our goal once we've matched them? What's our goal? What are we trying to find?
Get new x and new y.
Yeah, But funny enough, you already got new x, new y. See how it's new y is equal to y minus 5 and new x is equal to 3x plus 2? You don't have to do anything. You're done. So look at the examples. Look at example 1, example 2. Can you see how we made it a bit different? This one was mumble jumble. This one was 5x dash minus 2 equals original x. You actually had to rearrange it to get x dash. This one you didn't have to do anything. But over here, I deliberately made it so that the x dash and the y dash ends up being like that. Because what students normally do, if they don't understand it, is at this point they start rearranging it again. You're not meant to rearrange it because you're trying to find x dash, y dash. So your answer is literally right there. Your answer is, this is your x dash. This is your y dash. And you figured it out, it was 3 times the original x plus 2. And for the y dash, it's y plus 2. That's it. You don't have to do an extra rearrangement because your goal is always to find x dash, y dash if you're trying to look for the sequence. You already got it. If you actually sketch this on a Desmos, you'll understand what's actually... I'll show you. I'll show you what's happening, okay? Yeah.
It's y minus 5.
Is it y minus 5? Oh, it is 2. Where did I get that y plus 2? Oops. Y minus 5. Thank you. I'll show you what's happening and how I sort of did it so that it feels a bit weird in this line here. This is what's happened. I gave you the original equation was 3x plus 2 squared plus 5, right? Usually it's the other way around. Usually you start from here and you go there. So you had to go up by 5, left by 2 and 3, and then make it a bit smaller, right? What I did was I reversed it. I start from here and I went back here. So that's why it feels like I'm actually just reversing it. It means if I went up by 5, I have to go back down by 5. If I move to the left by 2/3, then I have to move to the right by 2/3. But what's funny is that already tells you all that. It already actually says move to the right by 2, and here it says move down. Because it's like you've already rearranged it all. Okay? So if you had to read it, let's read the transformation. Dr. T. What do we have? Let's go. What does 3 do to the graph? What's this 3 represent again? Dilation. So you would say dilation of factor 3, good, from y-axis because you're affecting the x-coordinates. There's no multiplications on the y, so that's all the dilations. There's no reflection because I don't see any negatives on the x or y. So you're really only left with now a translation. Translation of this plus 2 tells me 2 to the right. And this minus 5 tells me that minus 5, what does it tell me? Down by 5. And you're done. That's exercise 7D. Okay, so example 1, example 2, I was just trying to show you how the variety of different problems you can get. The goal is to find x dash, y dash. Okay? On the back of the page, there's one more example. That's for you to try. I'm going to stop the video here, but that's 7D. You want to do 7C first. Feel good about it before you do 7D. 7E is just applications. Okay, so you're sketching the graph. But start off there. Thanks, Tim. I'm going to stop the video.